So today I'm going to talk about AI in cyber. And I know that this is a big data conference and we're going to be talking a lot about big data, but the reason why I think AI is valid here is because, well, AI and really machine learning is valid and is an applicable use purely because we've got the benefit of Moore's law, so increasing processor power across the years, and the fact that we've got really large data sets to train a lot of the existing machine learning algorithms. A lot of what we're using is actually fairly old, relatively speaking. And if we think about some of the stages in the evolution of AI, there's a big burst, a big bubble in the 60s and 70s that kind of petered out when, well, frankly, we didn't have the computing power or the data sets to run through the algorithms. And what we're starting to see now is that benefit. So benefiting from different techniques and capabilities has really brought us to this point. And so big data is one of the things that makes current machine learning techniques possible. And so what I'd like to talk about is some of the more, I guess, esoteric things with regards to where it's being used now, where it should be used right now, and where we think it could go in the near term. There's all kinds of really interesting speculative stuff about robots doing your homework for you and cleaning your teeth and all that kind of good stuff. But that's quite far off. If you ask any of the experts out there, they'll say, well, anything from 30 to 40 years, a bit like fusion energy, or up to later on in time, or never at all. It's a really interesting book called Superintelligence by a guy called Nick Bostrom, which sets out the evolution of AI across time, and also highlights some of the challenges and opportunities and strategies we'll need to adopt. But specifically, this is with relation to the use of AI in cybersecurity. Before we go into that, a bit about Zonefox. This is Zonefox, a company that I'm a founder and the CEO of. And basically, we provide insights to our customers, some of which are up there, into what their employees are up to within the organization. So we provide information on data flow, whether Bob in HR is acting more like Alice in engineering. And if he is, you probably want to look into that. So we've got lots of experience of gathering large amounts of data, running machine learning algorithms across, some of which we've created ourselves, and using that information to inform security operations teams as to what next steps they need to take. And part of this presentation is about, well, how can we help the human? I think that we always forget about the human element. The main point of interaction we have on a day-to-day basis with our customers are, well, people have to feed and water and run these systems, and we often feel that they're overlooked. But to start with, I'd like to put this up here. Does anyone know what this might mean with relation to artificial intelligence? Okay, good. So Stephen Hawking, who we sadly lost this year, wasn't a fan towards the end of artificial intelligence. He thought it could kill us all if not tamed and directed in the right way. And of course, the press took it upon themselves to say, Stephen Hawking hates AI and thinks robots will eat us all. And that's not actually what he was saying. He was saying, yeah, there's a huge risk, which is why we've got to get on it, and we've got to really understand some of the fundamental issues with the things that we're creating. And you can already start to see some of these, what I guess you call unintended consequences. So at the ridiculous end, at the absurd end of the spectrum, you've got the idea of, you get an AI, it's been designed, it's pretty smart, you say, AI, make my friend smile. So it takes your friend, puts him in a chair and hooks him up to the mains. And the rictus grin he gets from being electrocuted is smiling. Did your job for you. Or maybe the AI goes into his brain and cuts chunks out and makes your friend smile because he's altered the pathways in the brain. So as far as the computer or the robot is concerned, they've achieved that particular objective. But it hasn't had the nuance or the subtlety that maybe you or I would take on board and maybe tell a bad pun, or, well, maybe not that, but, you know, a good joke to make the person laugh. Paperclips up here is, well, there's a game here. If you ever have 2 days without anything to do, try and play this game. And it is literally just clicking buttons, but it's fascinating. The conceit, well, I guess the scenario in the game is you have told your AI robot to maximize the output of paperclips. And so what your AI factory does is it makes drones which go out and harvest material from the planet and the solar system until eventually it consumes the entire planet, goes out to the solar system, consumes the entire solar system, goes out to the universe, and you get to a point where you can calculate the amount of mass in the universe and how many paper clips that would create, because you told it to maximize the number of paper clips. It's a logical outcome in a lot of respects. So we're thinking about unintended consequences here, and these are, I get it, these are ridiculous examples, but they highlight some of the things we do need to think about. So let's think about some of the decisions that may be made with some of these algorithms. I guess we could classify this as a black box problem. And we're starting to see them today. We're starting to see them with various recruitment robots that are used to give someone a test, a personality test, before they go along for a job. And there's already been reports and complaints that some of these robots are biased towards certain ethnicities, to certain genders, and these biases have been built or been inadvertently put in by the people who create the algorithms behind them. And so I believe in the US, they're starting to grow a movement of people who are wanting to sue the creators of these or the companies that use them because they say they're not fair. I can't get through this robot wall because it is inherently biased against me. And there's a really interesting class of research into that. Some of the counter research to help solve the black box problem is, well, it can be highlighted by this. We're at a point now where we've got sufficiently complex algorithms, so deep neural networks, where we simply don't know how the decision was made because of the various multiple pathways that are built up. This research is really interesting. It is basically a machine that'll say, this is a person mowing a lawn, and the reason why I'm saying that is because he's sitting next to a lawnmower, or he's on a lawn pushing a lawnmower, or we have a differentiation in activities. The activity is mountain biking or road biking. Mountain biking, yay, road biking, boo, for any cyclists in the audience. Sorry, Matt. So the machine has described why it thinks that one sport is better than the other. No, I didn't say that. I'm not going to get into that holy war right now. But it said, these are the reasons why. And when we think about the application of AI to security, this is really important. For things like, we develop an agent that goes on an endpoint, and we have had this agent classified as a virus by VirusTotal in the past because of a false positive. And I can't even begin to tell you the massive pain it is to contact a faceless bureaucratic organization to get this thing declassified and prove that it's actually a benign, lightweight piece of code. In the end, we managed to get there, but it took months to do. If you have an algorithm making these decisions, what's your recourse there? At least with VirusTotal, we could speak to a person. We could speak to Symantec, for example, who originated the false positive. We spoke to individuals there who gave us the insights on how to fix this problem. If it's a computer, how are you going to get that kind of recourse? How did it reach that decision in the first place? And so this research, very interesting. The idea is it's got to be able to explain it at the level of a 9-year-old. So we've got the black box problem. How do AI algorithms make their specific decisions? And then we've got really cool, interesting stuff, adversarial AI, which is, so we've all heard about AI spotting anomalies in systems and flagging up zero-day malware that uses zero-day exploits. But the guys who create this stuff, the guys and girls who create this stuff are not stupid. They're using AI against these particular systems. It's another arms race that we're locked into. Everything is a perpetual arms race in the cybersecurity industry. And an early example of adversarial AI, which is basically tricking the algorithm or the filter you're putting onto it, is, do you remember spam? When it came through and instead of an I, it was a 1. I thought, okay, great. Well, now I's are 1s, and then it got worse and worse, and then the filters caught up, and they reclassify spam in different ways, and now you get spam with chunks of text in it, and then the main message, buy Viagra now, then you get, Wuthering Heights at the end or something like that. So you've got all these different things to try and confuse the algorithms that we have. Remember that we're simply using machine learning techniques here. We're using an algorithm that takes a sea of data and identifies outliers and compares two extremes, effectively. And if you can trick it, you can trick it into doing something you want it to do, which is effectively what adversarial AI is. I guess the most famous example of this is, it's a presentation by me, so we need a cat picture in there, but what they did was they overlaid a filter across the cat image, and they made it slightly boxy at various points. So the algorithm thinks that the cat is actually a computer, which is highly problematic for the internet, especially lolcats and all that kind of good stuff. So this is an urgent problem that needs fixed straight away. And this is simply to do with the way in which the algorithm processes the image. It doesn't look at it in the way that you or I would. We look at it in different ways. We take a whole view of it. It basically breaks the image down into pixels and does various area recognition and compares it against what it knows about. So for it, there's a blockiness there. It says, right, that's a computer. Or Google Brain here. We've got toasters looking like bananas. So we've got this banana here and this weird kind of blob there has misclassified it as a toaster. I don't know if that actually is a toaster. Now, it is an arms race. We're starting to see malware defeating AV, but in looking into this topic, it's a really interesting research topic for any of you out there who want a research project. It helps us improve the algorithms. It helps us reduce false positives, and it helps us improve the way we go about these various things. So, black box problem, adversarial AI. What other problems do we have, or challenges, I should say? Inappropriate use of AI. I'm going to put my cynical tech hat on here, which is, as an industry, we're really good at generating hype about the new technology. So we say to everyone, you should apply this one thing to everything, because it's a silver bullet. And if Rich is in the room, blockchain. You see blockchain everywhere. Yeah, it's a great technology, but is it going to solve everything? No, it's not. But you get a lot of this we're at a big data conference. I've spoken to lots and lots of customers who've been told to go out and collect everything, and now they have petabyte data lakes, and they have a Python script to process it all. And they didn't know why they were doing it in the first place. They were just told, oh, it's a good idea, it'll come in really useful later on. And really my point here is, you've got to understand why you're collecting all this data, otherwise you're just collecting data for the sake of it. And the use of machine learning algorithms don't work really well with just random data being thrown at them. You need a data scientist. You need someone to sit down and engineer an approach that allows you to use them effectively. So if I think about, say, network traffic, there's lots of really interesting features in network traffic, but you're probably going to get to a point where you have too many features to use efficiently with a lot of algorithms. So you could probably do an analysis of a gigabyte of network traffic, and you could probably get some sort of result from that, analyzing all the features, comparing to network traces. And that might take hours or days, which is great if you have hours or days, but a lot of the time this needs to be done in real time. So what's that trade-off between enough data, so it's that Goldilocks zone, enough data versus too little data, so high false positives, versus too much data, which will just take ages to run. You just won't complete. So you need a specific problem. And in particular, we think about it in terms of the 3 C's. So completeness, consistency, and continuity. Where completeness, you have just enough data, not too much, not too little. You don't have extraneous logs being pulled in and analyzed. Consistency, you don't have to fill in the blanks. So the data's always there, so you don't have to do any normalization across the data set. Someone just have to sit there. And then continuity, you can get the insights whether someone's on a MacBook or on a Windows 2000 server. If you weren't using Windows 2000 server, please don't. Definitely upgrade. That'd be great. Thank you. So the 3 C's, which is what we look for to make this an effective approach, which, if you think about it, is kind of where we are with regards to the state of current AI activity, which is you've got some pretty spectacular results, but they're really narrow results. So you've got chess AI, I'll beat the best human. You've got AI that will drive a car and generally get you from A to B fairly safely. You've got AI that will play video games after hours and hours of training and so on and so forth. Or you've got AI now that will play Go to a really, really high standard. And each of these areas are great, but they're very, very specific. They're narrow. They're what's known as narrow AI. And to get to the point that Professor Hawking or the media are worried about, we need to get to artificial general intelligence, or AGI. So you need to be able to invent an algorithm or a machine, or have a superhuman capable of playing chess and driving a car and brushing their teeth and making breakfast and playing Go at the same time. That's when we need to start getting worried. But we still have very narrow applications of these particular algorithms. And as a result, we need to make sure they're deployed in the right way. And what about humans? I said a little bit about humans at the very start. Humans, us poor fleshy blobs in front of the keyboard, are often overlooked. We're actually really good at a lot of things. We're really good at making complex ethical, moral decisions. So in a less than fast-moving environment, you probably wouldn't get a human classifying malware or responding to it, but you probably want a human to say, actually, we should keep Bob in his job because he accidentally accessed that folder or he accidentally did a thing. I can understand that context. The issue you have with using AI to potentially fire people is, I was fired by an algorithm, I'd like to sue you, please, because how do you know that it made the right decision? Which goes back to the black box problem, which goes back to bias. You can't have machines making these decisions yet because we're not there by any stretch of the imagination. And we're really good at pattern matching as well. Given the right data at the right time, we can spot things a lot more effectively than machines can. Now, I say that qualified on the fact that a machine has gone through and pattern matched and given you a representation of their data set. Clearly, getting someone to scroll through a PCAP file isn't very efficient, but if you can represent that in a certain way, then you've got a really good chance of the human making the right decision. So that's where AI can aid these particular areas. So just to bring some of this together, where should we be applying AI right now? Replacing humans where errors are common, problematic. So machines are really good doing things over and over again really quickly and designing out the mistakes. So there's a really great startup called DiffBlue who are basically implementing code-level testing. And the reason why I'm a big fan is because what's the majority of security flaws come from zero days, programming mistakes, implementation mistakes. Let's design that out. We're really bad at consistency, and we're really bad at making sure everything's lined up perfectly, especially in vast data systems. So let's get the AI working on that particular problem. We should be designing it and putting it together, and we should get our robot friends to actually build the code-level stuff, because they'll design out the mistakes in theory. We should replace people in a fast-moving domain. So malware analysis, churning through large amounts of data. We're already starting to do that with a lot of the advanced AI out there. And then augmenting humans, so aiding decision-making and detecting and acting upon incidents, so incident response. And to highlight this a little bit, I'd quite like to go into a classic case study that we have that I'm sure you're all bored to death of already. You've heard me talk about it a million times, but this particular spin is quite interesting because we went into an automotive organization, we did a deployment, and basically we found one of their engineers packaging up and taking data from the network to take with him to a new job. And we found this out over a period of 5 days. And basically the individual sat down on his machine, managed to circumvent a number of controls on that machine and go out to various file shares that he shouldn't have had access to. He installed software he shouldn't have installed, and he plugged in a USB drive, which he shouldn't have, in theory, been able to do. And we at Zonefox, we helped the security operations team at the organization in order to identify and react to these things. The final reaction was go to HR, find out whether anything's going on with this individual, and he'd handed in his notice, which is why he was collecting all of this data to take to a competitor. Now that was all enhanced by the fact that we had this view, slow down view of what was going on at the data layer. But we got to thinking, well, what if you could design out some of the more mundane stuff there? What if you could react a little smarter, a little more effectively? And to think about that a bit more, we've got to think about basically what we call the insider threat kill chain, which is someone will be recruited to do something malicious, or they'll get annoyed and they'll hand in their notice. They'll typically do search and reconnaissance, so where's the cool stuff I want to take with me? They'll do exploitation, and in this particular case, it wasn't a fancy 0-day. He knew the domain admin password, so it's dead easy for him to just go, oh no, I'll turn off that control. Acquisition, taking lots of stuff from around the network and putting it into a single staging area. Then exfiltration, for him it was a USB drive. Now there's lots of areas here where we could have maybe automated a response. The recruitment point, that's tough, that's a soft problem. That's something that needs to be anticipated by management and good process there. But what about search and reconnaissance and exploitation? What we saw indicators of that. We could see alerts coming up. How about reducing his privileges until you investigate that incident at that point? How about putting a brake on various activities? I'm not talking about DLP where you simply just block stuff, but taking a smarter approach. Or maybe even suggesting to the security operations people, I've seen 2 or 3 of these particular activities in a row. Here's what I would suggest as a playbook to resolve this particular situation, or just look into it. And here's the data why I think reason A is what's going on, or reason B, for example. And then you could do the hard stop at exfiltration. If for whatever reason the humans haven't intervened or you haven't set up your system in a certain way, then when it gets the exfiltration stage, just cut it off. If it's suspicious, you see indicators of compromise, just get rid of it. And so this is where we see that kind of augmentation of human capabilities really coming into its fore, where we can learn the preferred responses of an organization. Some of our customers wouldn't want any of this automated. Some of them would like part of it to be automated. And that's where we can train these algorithms in order to take a response. Kind of like, your Amazon preferred purchases, but hopefully you won't end up with a Ricky Martin CD, as I did after I bought my sister a present, but that's a different story. So we're still at a pretty early stage. We're in I guess we call it the second bubble of AI. We've had one already. Let's descant Bayes a couple hundred years ago. So we're in the second bubble of AI. There can be unintended consequences. But I think these are further down the road when it comes to really sophisticated things. But when it comes to bias, when it comes to designing in issues into the algorithms we use today, it's a live issue. It's narrow, so it's only good for certain things at a time. We can fool it. We can think a banana looks like a gun. It's often used inappropriately, so let's throw it at everything. And human interaction can often be an afterthought. They're not often there as the primary benefactor. So, in our opinion, AI should be used to help us. That's why we call what we do augmented intelligence. It's there to help the individual to respond to their job a lot faster because, again, number one issue, not enough people out in the industry, always firefighting. So if we can help our teams make incremental gains, we're onto a winner. Thank you for your time, and be happy to take any questions, or I don't know if we have time for that, Basil, but thanks.